Hello everyone, this is Steve. We're going to graph this rational function here, which is actually one of our more frustrating rational functions to graph, and I'll show you why. First of all, we want to identify the domain of this rational function. Now, when you're trying to find the domain, you ask yourself, what numbers do I need to kick out because they make the bottom equal to 0. However, if you set x squared plus 2 equal to 0 and try to solve that for x, you're going to end up taking the square root of a negative number. What that means, everyone, is there are no real values that make the bottom 0. Which means this rational function, unlike many of the other ones we look at, actually has a domain of negative infinity to infinity, meaning the graph is continuous, or another way to say that is all one piece. And because we didn't kick any numbers out of our domain, that means we have no vertical asymptotes either. If you don't kick anything out of the domain, you can't have a vertical asymptote. All right, so far we don't really have much help. Now, horizontal asymptote, we can find one of those because horizontal asymptote is found by examining the degree of the numerator and the degree of the denominator. Now, if you examine the numerator, it's actually a degree 0. A constant is considered degree 0, and the denominator is degree 2. And if you ever have a degree on the bottom that's bigger than the degree on the top, there's no math to do. The horizontal asymptote is just y equals 0. That is the x-axis itself, everyone. Okay, now, x-intercept. Well, good luck with this, because if you try to find the x-intercept, you set the top equal to 0, and you find yourself asking the question, when does 8 equal 0? Never, so there's no x-intercept. Y-intercept? There's a y-intercept because we didn't kick anything out of our domain, so we're definitely allowed to plug a 0 into this function. So with our y-intercept, we plug a 0 into the function, and you will quickly get 8 over 2, or 4. So our y-intercept is 0, 4. But really, after all the dust settles here, we're looking for asymptotes, domain, x-intercepts, y-intercept. The only two things that we really have found out to help us draw the graph are the horizontal asymptote of y equals 0 and the y-intercept is 0, 4. So I'm not sure what we're going to do. Let's go to a graph and see what we can do. Not a whole lot to go on here. We do have a horizontal asymptote, which is y equals 0. And we do have a y-intercept, which is 0, 4. What else do we know? Well, we know the graph is all one piece, and we know that we never cross over the x-axis. So we're not going to draw anything down below. So nothing down here, because we have no way of getting down there because we're not allowed to cross the x-axis at all. So I know I'm eventually going to have to hug this asymptote here. The question is just what happens on my journey out towards the left and right. So what I did was I plugged a few numbers in here. I plugged in a 1, I plugged in a negative 1, I plugged in a 2, and I plugged in a negative 2. And when I plugged in both 1 and negative 1, I got 8/3, which is, of course, just a little bit bigger than 2 or a little bit less than 3. And then when I plugged in 2 and negative 2, I got 8/6, which is 1 1/3. And what I realized was at this point, this is actually an even function, everyone. And if you don't remember what it means to be an even function, it means putting in a negative number is the same as putting in a positive number. Because whenever you plug a number into this function, the only place you plug it in is right here, x squared. And whether you square something negative or square something positive, you're going to get the same result. So that's why this graph is actually going to be symmetrical over the y-axis, because it's even. So 8/3, 2 2/3, so let's see what we got here. 2 2/3 right about there. And then its friend over here. And then 8/6, is 1 1/3. So right around there, right around there. So actually what happens, and this is a little bit hard if you've never drawn a picture like this before, but it actually kind of curves out like that. Just making this little pile here. And that's actually the graph of our rational function, but it looks a lot different than our other ones because it has no vertical asymptotes. Let's see what technology gives us. Well, I graphed it on a computer and this is what I got. And I'm not sure if we really could have done much better. So it worked out okay. I hope that helped. Thanks for watching.